stellar spectroscopy, we can tell a lot about a star from its spectrum. That means the full range of wavelengths it produces. Firstly, let's remind ourselves of the absorption spectrum from topic 7. A star, of course, has its core where it's producing energy, and that's a plasma, which is pretty much a perfect black body. So it produces all possible wavelengths. That's perfect white light, and by white I mean the entire spectrum. But the outer layers, they're too cold to be a plasma. They're mostly hydrogen. So we get the absorption spectrum. White light comes out, and hydrogen absorbs every wavelength it can absorb. So we get something like this, basically the full spectrum, with particularly the hydrogen spectrum missing. But that's a simplification. Let's look at how much, what intensity of each wavelength we get. It's something like black body radiation, because as I say, it's mostly just a plasma without much taken out. Mostly just a plasma, but missing a few little bits. But first of all, intensity here, we can tell from its peak wavelength, of course, by Wien's law. We can tell its temperature. Not equals temperature, but gives us its temperature, its surface temperature. So what can we tell about a star from its spectrum? First of all, its surface temperature. But if that's a black body, it's not quite a black body. Of course, we can tell its chemical composition. So actually, there'll be little bits missing. Like I said here, there'll be these wavelengths in particular missing. And actually it looks sort of crooked or raggedy here. They're missing, and we can tell how much they're missing. So we can tell from this one that the outer layer at least is hydrogen, as you would expect. But there'll be other little bits missing as well. Missing perhaps like this. And we can tell that there are other chemicals in there. So even though the heavier chemicals, helium for example, we pull by gravity mostly into the core, there's bound to be a little bit of it swirling around in the outer layers as well. So we can tell its chemical composition. So surface temperature and chemical composition. So that's important. So again, by the absorption spectrum, we can tell its chemical composition. So we can tell what percent of it is hydrogen, for example, what percent of it is helium, etc. That's how helium was discovered. Interesting. What else can we tell about this? From its chemical composition, we can tell something about the kind of star it is, if it's a main sequence star. Spectroscopic parallax relies on the assumption, of course, that it is a main sequence star. So you'd have to tell that from its spectrum. If it has got other chemicals, say if it's got more and more helium, that means it's an older star. You can also tell if it has trace elements of heavier stuff, some uranium, some gold in there perhaps, or medium-sized stuff. That would tell you maybe it's a second or third generation star in that it contains the remnants of earlier generations of star. So you can tell something about its age as well. So chemical composition tells you what kind of star and its age. I'll put kind here, by which I mean, is it main sequence? Is it red giant? That sort of thing.